Okay, everyone. So what we're looking at today is a concept known as Ohm's Law. And really, this is a calculation that shows the relationship between voltage or potential difference, current, and resistance. So the formula here is V is equal to I times R. So V, of course, representing potential difference. The unit here is in brackets. Okay, so we know that the unit here is volts. I is representing the current, and the unit of current is, of course, amperes or amps. And the capital R is representing resistance, which we know is in units of ohms. Okay, so it's very important that when you're doing this, the units must match this. So meaning, and let's quickly review this. So let's say I had volts and we have millivolts or kilovolts. So to convert from millivolts to volts, right, what you would do is divide by 1,000. Okay, and if you had to convert to volts from kilovolts, you would multiply by 1,000. Okay, and that goes for everything. So amps, milliamps, or kiloamps, ohms, milliohms, or kiloohms. Okay, it is only the base unit that can be used with the formula V is equal to I times R. Actually, to be honest, that's not entirely true. You can use any of them, but they have to be consistent. So if voltage is millivolts, that means this would have to be milliamps and milliohms. Okay, you can't have some of them being one unit and some being the other. Okay, but generally, all of the calculations and stuff that I'll show you will be making sure that it is the base unit. Okay, but the point is you need consistency. Okay, also just to recap, right, how to rearrange formulas. You should at this point feel comfortable doing this. So V is equal to I times R. So let's say we wanted to isolate for I. We would have to essentially do the opposite function. So because it's being multiplied by R, we would have to divide by R on both sides. So in other words, I is equal to V over R. Okay, going back to the original one. Let me erase this here. Oh, okay. Okay, so V is equal to I times R. Let's say we wanted to isolate now in this case for R. Again, it's the opposite function. If it's times I, you divide by I on both sides. So R would end up being V over I. Okay, it's a simple 3-variable formula. So at this point, you should be okay with doing this. Especially density was a 3-variable problem as well, right? Okay, so let's start looking at solving for examples here. So keep in mind, we're going to be using grasp. Okay, anytime you're doing a short answer, or I should say like a word problem, where you're doing calculations in science, you're going to be using grasp. So we're going to do the same thing here. So it says a current of 4.0 amps flows through a 40.5 ohm resistor in a circuit. What is the voltage, which is the same thing as potential difference? So we're given current is 4.0 amps. We know resistance is 40.5 ohms. So remember, just by looking at the unit should tell you or indicate to you what the variable is, right? If you have amps, we know that that's current. If you have ohms, it's resistance. If it's volts, then we know we have potential difference. And of course, we're looking for the voltage, which is the same thing as potential difference. So this is just our original formula, V is equal to I times R. So the units are in the proper format. So we're going to simply plug in here. So we have 4.0 times 40.5, which gives us 162 volts. Okay, so now we're going to look at significant digits. So 4.0 is 2 sig figs, 40.5 is 3. So that means my final answer here, I would have to report this to 2 significant digits, which would be 160 volts. And then, of course, we need a therefore statement. So the voltage in the circuit is 160 volts. Okay, let's take a look at the next one, and then I'm going to have you try one. Okay, so we have a 0.050 kilovolt battery generates a current going through a 10.4 ohm resistor. How much current does the battery generate? Okay, so again, we're using grasp here. So we have our voltage, but it is in units of kilovolts. Okay, so I'm going to recommend that you change this right here, right now. Okay, because what happens is if you don't change the units from the beginning, sometimes students tend to forget to do that later on. So let's recap, right? So to go from kilovolts to volts, we're going to multiply by 1,000. So that's going to be basically 50 volts, right? And our resistance is 10.4 ohms, and that is in the proper unit. We are looking for current, right? So current, right? So let's recap here, is V over R. And then I'm just going to continue up here. So we have everything's in the proper unit, so we're going to plug this in. So we have 50 divided by 10.4, which is 4.8077, etc., etc. We're not going to use all these digits because we're going to have to round this now. But the unit, again, is in amps, right? So for significant digits, both of these have, actually, sorry, not both of them. Our voltage value has 2 sig figs. The ohm value has 3. So we need this to 2, which is 4.8 amps. So the battery has a current of 4.8 amps. Okay, so here is one for you to try. So a refrigerator is connected to a 240 volt outlet. If the current on the fridge is 51 amps, what is the resistance of the fridge? So pause the video and give this a try. See how you do. Okay, so let's take a look. So we have the voltage, 240 volts, and we have the current, but it is not in the proper unit yet, 51 milliamps. So to go from milliamps to amps, we have to divide by 1,000, which will give us 0.051 amps. And we're looking for, in this case, resistance. So resistance is equal to, right, V over I after that is arranged. So now we can plug in. So we have 240 volts over 0.051 amps. So 240 divided by 0.051. So we get 4705.88, but we're not going to use all those digits. Okay, so we want both of these now. In this case are 2. 240 is 2. 51 is 2. So remember, you always go back to the original question. So to get this to 2 significant digits, we would have to round 4,705.88 to 4,700. And then, of course, the fridge has a resistance of 4700 ohms. There you go. So that's Ohm's law.